Hi, good morning, everyone. Thank you for joining this session. It has been a very long weekend, a long week, and looking for the weekend. So I know some guys have probably on the way to home in the airport, and some of the others probably on the beach. So I really appreciate you guys' time with me. And to be honest, I don't expect so many audience here. I'm working for Microsoft as a Premier Field Engineer, and I have met a couple of you guys here during my customer engagement. I believe most of you have heard this Azure RMS a couple times in different sessions. Personally, I have been in different sessions. I heard people talking about this more than 3 times. So this session certainly is a deep dive into this Azure RMS, nothing else. Even we couldn't cover all of the aspects of Azure RMS, but I'll explain what's the main question I'm going to clarify in this session. So Azure RMS, as you guys probably understand and learn from this week, is a technology to protect your information. So let's have a look what data we have in our corp network IT environment. So we categorize the data into different categories. Structured data, of course, and the other one is unstructured data. And structured data essentially means the data is centralized and managed by specific design software, like a SQL Server software and Exchange, like typical one probably Exchange Online, Office 365. I think someone mentioned about the hard disk level encryption like BitLock, and the column, in terms of SQL, you can do row level encryption. On Exchange, you can do container level encryption, and for SharePoint, you can do file level encryption. So that is not the focus of this Azure RMS. Azure RMS is designed to protect your unstructured data. As you can see from the bottom of this slide, unstructured data amounts to majority of the data in your IT environment. And what is unstructured data? Any data which is not structured and can be created by anyone, stored in any devices, and that's the focus of Azure RMS. So I do have lots of slides to cover. I just want to clarify that I might not be able to answer a question during the session, but I'll try to run through all the slides and have some time to do some demo, and during that time we can have some interaction. So let's have a look at the problem with the data leakage. And I don't think I need to highlight the risk of data leakage. And you probably often to see from newspaper websites about some data leakage incidents happen with some organization, individuals. And this is a typical example. And the company has to give the employee access to the sensitive data. But when the employee left the company and joined the competitors, and the employee still have access to data, as a result, causes this kind of incident or disaster. And Azure RMS can prevent this kind of issue from happening. And more examples, and quite significant incident with the space station control code leakage. Yeah, the other one, I guess, as Australian, we probably well know this wake leakage. To save a bit of time, so when you first think of who have done this, caused this data leakage, the first category of person coming to mind probably the hackers. But if you look at the right corner, you can see the most contribution. The majority of people who contribute to this kind of incident is not hacker, but your own employees. So Azure RMS not only will protect your information document from accessing by malicious users, hackers, but also will prevent your own authorized users, employees from doing the wrong thing, or also prevent them from misusing the information. So let's have a look what is the common practice these days in most of customer IT environment. The way we secure data these days is location-based. What that means, A typical example would be you have file share on file server or file cluster, and then you delegate the permission to a group of users based on the group of membership. And we know, I have done lots of engagement with customers. That's going to be a very common practice. And some customer has used this message to a very extreme level. I'll give you an example in which I work with government agency. They got a very significant incident. They create a file share on file cluster replicated by DFS replication service across multiple servers and backup on 2 loads daily. There's one file share which is specifically created for the minister. So because they don't want anyone else from accessing that share, so they only grant the minister permission to that share, which means they remove system credential from accessing that share. So when I went there, because the problem they got was the data was lost. So I work in there. The first thing that they really want to do is blame Microsoft, because only ministers have the access to the file, and nobody else can access to the file. And the minister has never deleted the file while those files are gone. So they want to blame Microsoft, probably our OS or any service who deleted those files. They told me because system account doesn't have any permission to the folder, and a domain admin, any administrator has no permission to the folder. So that's the argument. So you can see I'll give you example and how extreme the customer has used this method to protect their sensitive document information. If you know this technology very well, you probably understand what I say. What the customer argue is incorrect. That's what adds more complexity to how you can really secure data. Why it's not correct? Why what customer argue is incorrect? Because when a user try to access a folder or share, and of course, if they have permission on the SEO on that folder, on the share, and the user will have access to the file in that folder. But also we have another system privilege called data backup restore. If any account have that privilege on that server, it will have full access to any data in the system. So probably half of your guys are not aware of this. So because of that, even though they don't grant permission to the folder, to the system still have access to the folder. Therefore, it can be replicated to multiple servers and has been backed up to multiple different tabs. You can sense then you can see the risk. So now the minister file has been on multiple locations on the different tabs in different backup devices. So this has been traditional method to secure the data. From the example I just explained, it doesn't really work anymore in the evolving IT world, because the multiple BYOD devices, we will have a look in next slides. The evolving IT world. This slide, so we have BYOD devices, and when you access the sensitive data, when the device is inside your network, and then you will take a device outside the network, it's become unmanaged. Then we have our Azure cloud provider. You can migrate your workloads, including your data, to our storage. Again, someone talked about the customer logbook, lockbox. We have some customers who are very concerned about how we manage the Exchange mailbox data in our Office 365. Even though we tell them the lock boxes, they're still not happy with that, because they want to know exactly how you do the delegation, how your engineer will see our data. So again, then this is very common for people to have OneDrive or Dropbox. If I take a photo here in the next couple of minutes, the photo will be synced to OneDrive and then will be synced to my laptop. So it's involving IT worlds. The traditional location-based backup is not really suitable anymore. So how can Microsoft resolve this problem? Yeah. Of course, we have many different solutions on many aspects to address this problem. But what Azure RMS or RMS try to address is explained in these slides. So, for example, we have a company, and we'll have different kind of data, right, in a different file format. And the challenge of this scenario is we can't restrict this data in our internal network. We have to let the user to access data. As a result, the data will go to somewhere else. Now, how we can protect the data? So we want to use a policy to define, say, for this type of data, we want only this group of users to have only read-only permission for how long. And then you also have the ability to see who have actually opened the file or who have actually tried to access the data. And then you can take further action if you need it. So we want a policy-based solution to address this risk. So how can we address this? Well, I think we talk about encryption in many occasions with many different sessions. So think of that. If we have a sensitive data which is not physically secure, which means physically is available to authorized users and also to unauthorized users. Now, how can the data be protected? So we have to encrypt them, which means if you don't have a key, you can't open them. And then we come to the next question. So if I create the file, I want to give user, let's say, George, a read access to the file. And nobody else can access that file. Then I need a mechanism to identify when George tried to open a document. If someone else opens a document, and then I will deny the access. So we need authentication access control. And this is work with Azure AD. So the RMS technology has been on the market since 2003, and the technology itself hasn't really changed. But the really changes deployment, the way we use this technology is integration with Azure AD. I will explain why that is so significant. So with these two methods, we can protect file if the user doesn't have a key, they won't be able to open them. Then if the user can successfully authenticate it and confirm the user has permission on the file, then we'll be able to grant access to them. But that's still not in life. We want to restrict the user how the user can access the document, the data, which we call enforcement. And how many of you guys have experience with Azure RMS in your network, in your environment? Yeah, not that many. We introduced RMS many years ago. So enforcement, which means we'll enforce even nowadays. So after a protected document, the file, and it will be encrypted, and you need a key to open the document. The enforcement will happen when the client has already got the keys, because for the user to have any access to the document, the user needs a key first, which means even we give the key to the client, or not the user, but the application, we still need further enforcement control on how the key can be used. If we don't have any control on the keys, which means once the user has the key, it will open the document, it can add it to whatever they want. So we want to control that. For example, if the user receives a document, we don't want the user to be able to forward the email, something like that. Sorry about that. Yeah, that's how Azure RMS try to address these risks. This is just give an overview on a very high level on how roughly it works. So again, this is still very high level. I will go very, very deep, and probably you have similar level of information from other sessions. Let's say this user have this document on his laptop, and he wants to protect this document, and that server represents the RMS server. So of course, you need to click a couple buttons to choose the option to protect document. Then, before the user can protect a document, the user needs to authenticate with Azure RMS. We need to know, first we need to know whether you are a valid user. Second, we then check your license. Right? You need the license to be able to use this service. Then after the user authenticated, the user will get a list of certificates. A set of certificates, not single certificate, a couple of certificates. So I heard someone mention in other sessions, so this is certificate-based solution. And certificate has been heavily involved in Azure RMS solution. So the copy of a certificate will be generated and dispatched to the client. The client will use one of the certificate to sign the license. What the license here means, it's just SEO. I guess most of you guys know SEO as well, very well, right? SEO just who have permission on this file, you know. They're similar. When you grant user access to the files, you can type the user's principal name and then for what kind of access you will grant to user. So that definition is called license. It's a little bit confusing here. So just be aware of similar with SEO. And of course, we need a key to encrypt the document. And all this license need to be signed by user certificate. So then this protect document will go to the consumer via any way. You know, could be email, could be USB disk. So but during the transition, this document is always encrypted, protected. Once the recipient receives the document, and so now this consumer of the document need to talk to Azure RMS to verify itself. And if it can successfully authenticate and then authorized by Azure RMS, the Azure RMS will give the license to the user. Therefore, the user can use a key to decrypt the document, to open the document. So I think this diagram looks quite logical, right? So it's not horribly complicated, but you must think of there's a risk on this workflow. So I have a question for you. You just bear that in mind, and the rest of content in this session probably just try to answer one single question. Because we talk about the key, which is used to encrypt a document, and I might protect a document to share with a group of users in my organization or some user outside of my organizations. But how can I share the key safely, securely to the recipient? That's a challenge. That's the most difficult about Azure RMS. And in the rest of the session, we will try to answer that question. So from this diagram, you can see how can the key, which should be decrypted by Azure RMS, be safely, securely sent from Azure RMS to the client. Because if we can't guarantee the safety, security of the key, then this solution is pointless. Yeah, after the key is received by the client, and as I said, the application will do application level enforcement, and based on the license, the permission given by the author to enforce, to restrict how user can operate the document. Yeah, it can be blocked on this operation level, like you can only have read, you don't have edit permission. The protection is persistent. As I said, once the document is protected, is encrypted, and the license will be embedded into the document whenever this document goes. So as a result, only the authorized user who can get the license from Azure RMS or AD RMS, they can decrypt the document. For any unauthorized users, first, they shouldn't have access to the physical file. If they do have physical access to the file, they won't be able to get the license from Azure RMS. As a result, the document will still be protected. I'll do a quick demo and just try to explain the diagram I just showed. This is my Microsoft domain join laptop. I also use we also use Azure RMS, so I'll use this laptop as part of my demo. So as you can see here, I have 4 RDP sessions. They're all on Azure. So first, I will open the Azure portal. I think you guys have seen this many times. I log in by using my Microsoft account. I'm trying to encrypt the document, then I come back to the portal. A little bit slow to save a bit time. I have two Windows client RDP session here. One is Windows 7, the other is Windows 8. Sweet. Okay, then let's say. So this is a very just a normal folder. I'm going to create a document. Make it simple, just a text file. It's a little bit slow. Yes, it's a little bit weird. Probably like the computer like me, a little bit nervous, then goes a little bit sluggy. Yeah, we'll probably come back late. I think the little collection is not that great. Now we have to come back a bit later. It's a bit weird. Yes, before we start this session, it's worked perfect, but now it's getting so slow. So we'll run through the slides, and then I'll probably try my 4G mobile to connect to the internet, to see. Hopefully, it can work better. So, as I mentioned earlier, this is deep dive into how Azure RMS works, and also Azure RMS is certificate-based security solution. And from this slide to the next demo is very, very dry. So this content might be very dry to most of the guys. But I try not to waste your time. Hopefully you can get something back from the dry slides up. As we mentioned, so if we want to differentiate the consumer, for some user, give the access to some users but not others, then we need to authenticate the users. And Azure RMS is developed based on AD RMS. And it has been quite complicated to try to use certificate-based authentication instead of relying on Active Directory or Azure AD. So when you do the first communication with Azure RMS, you need to authenticate with Azure ID, which will be redirected to Azure RMS. And after you successfully authenticate yourself, the Azure RMS will give you a set of certificates. One of the certificates will be used for further certificate-based authentication with Azure RMS. And that's the way how you can protect document when you are logged online. And then when you protect a document, which can often happen when you are offline because you have already got this certificate from the Azure RMS. And the protection, as we discussed earlier, will remain embedded inside of document. And when you use a consumer document, you will contact RMS, authenticate, and get license, and then encrypt the document. I think we just repeated the diagram we discussed earlier. So when the author of this document try to protect the document, this user will get a list of certificates from Azure RMS, and use one of them to sign the access control license, which will be embedded inside of the document. The document then will be distributed to the consumer of the document. Then this user will contact Azure RMS to receive a user license, including the encryption key to open the document. The triangle icon on the side just means the Azure ID or any authentication. If you have federation, you will you will authenticate with your local on-premise Active Directory. The database icon is a database for Azure RMS. Azure RMS does have a very complicated internal database for certificates for logins. There's a couple of components involved to achieve this complete IMS solution. First is Azure or IMS server, which will issue a certificate to the author of the document and also the consumer document, and issue the license to the consumer of the document. And we also need Azure or IMS client. We have a couple of different versions of IMS client. And then to achieve the enforcement, the application needs to be IMS or await. The typical one will be our Office application. So the Office application will have the IMS plugin. Once you have that installed, it's a part of IMS client. Then the application can do the application level enforcement to only give certain access to the document based on the license defined in the protect document. As Azure RMS, from the name we know, it's based on Azure. So this change from on-premise to Azure has also made some significant change in terms of how the client can talk to Azure RMS. If everything is deployed on your core network, the client and the server can talk on any protocol they like, like RPC on any port or authenticated through Kerberos. But if the service is deployed on Azure, then the client will talk to the server through the public internet. So the communication protocol has to be internet friendly, which should be HTTP or HTTPS. And again, authentication with even your on-premise ADFS or similar security token service or Azure AD had to be through the HTTPS and through security token services. The KMS is responsible for any key-related, cryptography-related operation inside of Azure RMS. It can integrate with Exchange Online, SharePoint Online, of course, Office 365, and also can work with your on-premise Exchange server or SharePoint server or Windows server to do automatic protection. Under the hood, so this is probably the most the dry part of this session. If you have tried to understand this technology, probably if you search the internet, you might find this very same terminology and similar diagram on internet. And because the IMS is a certificate-based solution, so I know certificate is not as well known as the Active Directory. I'll try to cover the very basic part of certificate, so you guys, therefore you probably have a better understanding on how the Azure RMS works. There's two ways of the encryption. The first one, one is called symmetric key encryption, which means we will use the same key to do the encryption and same key to do the decryption. The other encryption is called asymmetric key encryption, which means we have two keys involved. If we encrypt with public key, we'll decrypt by using the private key, vice versa. And I think this is fairly easy, very straightforward to understand. You have the same key, you encrypt something, then you decrypt something by using the same key. You might think this is old school, but it's not. It's very heavily and intensively used on any encryptions. The reason why is because it's cost effective, it's very efficient, and it's very, very fast compared with the asymmetric keys. Asymmetric key encryption is only invented a couple of decades back, but this has been invented as long as human has history. But the problem of this is how you can, if I want to encrypt something, I'll give the document to you. How can I give a key to you, right? If I want to give the document encrypted to hundreds of users, how can I give this symmetric key to my recipients? That's the challenge. That's the challenge. Sorry about that. I'll just skip one. This is probably the most important slides, one of the most important slides on this session. So the public key encryption, because the challenge of sharing the symmetric key, we need this public key encryption to exchange the symmetric key. And I'll give I usually use a very related example of how we access our online banking website. I do that probably not daily, probably weekly. And so if you access your online banking website through HTTPS protocol, of course, all the traffic has to be encrypted. Otherwise, your money probably gone, right? Then, as I said, the symmetric key encryption is efficient, and this is very costly, very slow, and some modern devices even don't have the ability to the asymmetric encryption. So the HTTPS traffic will have to be encrypted by using the symmetric key, as you can see from the second item here. So when you access the online banking website, you will download the public key of the SSL website certificate. The public key is not secret. It should be public to everyone. So you will get the public key, and then you will encrypt the SSL traffic by using the randomly generated session key, which is symmetric key. And then the traffic will be encrypted, and the key then will be encrypted by using the SSL certificate public key and sent to the website. So this Swiss traffic might be eavesdropping slipped by many attackers on the past, but only the website which has the private key can decrypt the symmetric key, therefore to decrypt the SSL traffic. And again, we will use the same method in our RMS solution in multiple different communications. So this is the same method to use on probably all the encryption. If you have EFS file, probably someone talked about EFS this morning. If you have encrypted emails, they all happen in this way. The signature, we've heard this many years ago, right? We can do our digital signature. So when you sign something, your signature will be very unique, which means nobody can replicate, copy your signature. Again, when you sign something, we have to use something which is unique to the user to sign it. So we'll use private key. How does that work with, let's say, with Azure RMS document? I mentioned when you protect documents, you will generate a license, which will define who have certain access on document for how long. Then that information will be called, it's called license. That has to be signed. Otherwise, someone can manipulate that document and can change the definition to grant access to the malicious users. So it has to be signed. How that works? Let's say I want to send a signed email to you. So first, we'll use a hash algorithm to create a hash value. The hash value just uses a very small amount of data to represent a very large amount of data. So you probably heard about SHA-1, SHA-2. We use SHA-256. So we'll create a hash value based on the email content or based on the license defined by the Azure RMS document author. Then this hash value will be encrypted by using the user's private key, as I mentioned. To sign something, you have to use something which is unique to yourself. So you will use a private key to encrypt the hash value. When the recipient receives the content, whether license or email, he will do the same hash against the content. It will gets a new hash value. Then we'll decrypt the hash value, the encrypted hash value by using your public key, because your public key should be public, and usually, and it will be embedded into the encrypted email, assigned email, or encrypt Azure RMS document. Then it will have two hash value. then we'll do the comparison to see whether they're the same. If the same, which means this signature is valid, the data has never haven't been changed. So that's how the digital signature works. So it needs to be over topic, but it's essential for you to really understand how this Azure RMS works and how we can confidently say this is very secure solution to protect your document. RMS certificates and license. So if you have experience of deploying this on your on-premise before, you will know you can install the license and certificate component on different server. Of course, they need to be clustered and also need to be proxy to the internet. So it's very complicated to deploy them on your on-premises. So yeah, RMS needs to provide the two endpoints for the user to use the certificate and license services. This is the author of documents with own laptop, and this is the consumer of the document. So we have a document. This is a certificate. This is the most critical certificate of a RMS solution. We call server license certificate. This certificate is held by the Azure RMS server. Any certificate will have two keys, public key and the private key. And the public key will be free to everyone, right? So you can easily find the URL, you can download the public key, but the private key should only reside on the server and highly secured. I think we use Thiel HSM, high security modules. We don't trust the software-based CSP providers. We use HSM. So the key will always sit inside. What does HSM mean? If you have experience with a certificate, I believe some of you probably have. You enroll a certificate. You don't have any additional device attached to your computer, and you just have a certificate. As I said, you have two keys, public key and private key. Now, where is your private key? Your private key is software-based key, which is stored in your user profile and protect your password hash. Again, if you lose a password, you will only be able to decrypt that and get your keys. And then certainly, if anyone have access to your backup, to your hard disk, and they can potentially steal your private key. Yeah, so we use HSM, not software-based keys. So when the client first initialize the operation to protect document, the Azure the RMS client will generate a client computer self-signed certificate. Self-signed, from the digital signature we just discussed, the self-signed means it's signed by itself. So the RMS client will generate the self-signed certificate. And you might have a question, why do we need this certificate? You will understand it in the next slide. And then the user will get a right account certificate from Azure RMS. This is a certificate issued by Azure RMS for the certificate-based authentication of the initial authentication. Then user will get another certificate called client license certificate from Azure RMS. And this certificate is used to sign the license, which is embedded in the protected document. This is the license which will be signed by that document, embedded into the document, protected document. And all this will be sent to the consumer document. Once this guy is authenticated with RMS, it will get the license. In the license, there's a key which can open the document. I know it has already been complicated enough, but that's not the end. So this slide is getting harder. But I promise after this one, it will become very easy. So let's have a look at the first initial communication between the client and the server. So when you enable Azure RMS, which is a couple click on the management portal or on Office 365 portal, you can. Sorry about that. Then you have your Azure tenant with your Azure RMS deployed, your key prevention. When you first choose protect document, and the RMS client will generate a self-signed certificate for you on the client. And then the public key of this certificate will be sent to the server, Azure RMS server. I know you all have questions why this happens. This is because we want to securely transport the certificate from the server to the client. And then the user needs to authenticate with Azure RMS, which essentially is authentication with Azure AD or then with Federated Trust, it will go to your on-premise security token services. So we only accept the user principal name, not the domain / because we have so many tenants. The domain name is the way we identify your tenant. Then the Azure RMS will check whether this user has already contacted me before, and then from its own database. If yes, they'll get a certificate from database. Otherwise, we'll generate this to a certificate for the client, and also store them in a database. Of course, because the private key has to be private, so we can't just simply store the private key in the database. It has to be encrypted by using the public key of the Azure RMS certificate. And then, of course, only the IMS server has a private key to open the encrypt certificate. And now, if you do follow me, you might have a question in your mind. How? Because when I mentioned earlier, when you create a certificate on your Windows through MMC console, you will generate the keys, the key pair, public key and private key, on your local user profile. Then you send the public key, for example, if you want to buy a certificate from VeriSign, you won't send the private key to them, right? If you send the private key to them, you won't be able to use it, right? How can you trust them? You will generate all the keys on yourself, on your side, and you only send your public key to VeriSign. They will sign that, I'll give it back. Then when you associate them, will become a valid certificate. So the private key will be stored on your end and never go to others. But you can see the difference between this scenario. The key used for Azure RMS client is actually generated on the server end, not on the client end. Then I have a question, because how can we transmit the private key safely? Right? Because the private key has to be private. It can't just transmit over network with clear text. Otherwise, there's no point. So that's the reason why we need to have that self-signed certificate. We'll use the public key of that computer certificate to encrypt it. Then we send it back to the client. I know this is overly complicated, so you don't really need to memorize this diagram. But this diagram will help you to make a decision on whether this is a solid, robust solution to choose. I have to love this because I got heaps of questions from my clients. I'll give you a couple examples, especially for the customer. They have the dedicated security team, and they usually have people in a team with good understanding on certificate. First, they ask me, we know this is a certificate-based solution. Do we need to deploy a certificate authority server in our environment? Now you know the answer is no, because the certificate will be generated by Azure RMS. So from that point of view, the Azure RMS essentially is a certificate authority provider. And so that you don't need additional certificate authority in your environment to use this service. The second question, which is quite, I guess it could be very common for people who have understanding on certificate. The customer asked me, if a user has a user profile cropped, how can user still access the protected document? If we have EFS, someone talked about EFS this morning. As I mentioned, if you create a certificate, you have public key, private key stored in your user profile. The private key will be encrypted by your user password hash. And if your user profile cropped, what will happen? You won't have access to your keys. If you have anything encrypted by that certificate, you will lose access. And if you have a long holiday and you forget your password, you reset your password, you have new password hash, and you won't be able to decrypt this private key. Again, you will lose access to your encrypted document. That's the reason customers have asked a question. So if the user profile cropped, if the user forget the password, can user still open the correct document? As from this diagram, you understand. Because the keys and the certificates is generated on IMS client, IMS site, and stored in the database. So we can always retrieve that information for you. You don't need to worry about it. Even you have complete cropped profile, no problem. We can still get that. Following a similar process, we'll get another certificate called client license certificate. Now let's have a look at protect. What is the detailed process of the protecting document works. First, we have document. We want to protect that. As we said, we need encrypted document. So we need a key. This is usually sometimes called session key, master key, which is randomly generated by the RMS client calling into Windows operating system. So this is fairly straightforward. So the documents will be encrypted. Now, because the challenge of this solution is how can we give this key safely to the recipient of the document? So the key has to be encrypted. Otherwise, if I want to be, the document can be easily opened by any hackers. So it's encrypted by using the IAM server certificate public key. So now we understand who can have access to this key. Only the Azure RMS server, because only the server has the private key of that certificate. And then the user will define who have access to the document for how long, for what kind of access. Again, this had to be encrypted by using the same server certificate key, public key. And again, it needs to be signed by the user because we need to make sure the integrity of this license. So all this information will be embedded into the document. So if I can do demo, then I'll show you the size change of the document. Yeah, so this, as a result of the protection, the document will become that. So the document itself will be encrypted. The key will be embedded and encrypted inside the document. And also the license is signed, encrypted, embedded into the document. As I said, usually you will have put your certificate and public key with the signed the content, whether email or document. Once the consumer receives the document, it will send the license, the encrypted key, to the server. Now, this is also the other very important point. From this diagram, you can understand we don't send your document to Microsoft, so you don't need to worry about that. So some customers say, if only Microsoft can decrypt the content, then that means we'll send everything to Microsoft. They will have access to our document. No, you won't. You don't send the document to us. You only send the encrypted keys and encrypted license to RMS. So the server will use the private key of the certificate to decrypt the encrypted key, and then we'll validate the user by check the rack certificate. We talked about the rack certificate is from the RMS server database. It will check whether this is a valid one, right, or it's a fake one. Then it will decrypt the license and check whether this user has the right access to that document defined based on the license defined in that document. And now, I think I asked this question before. Now, how can this encrypted key, which is decrypted on the RMS server, can be safely given to the client? Now, the answer is because the key will be re-encrypted by using the user's certificate public key. Now you can see that all the license and the keys has been encrypted by the user's rack certificate public key. Then the user will use their own private key of that certificate to decrypt the license and the encrypted key. Then you will be able to open the document. Let's see if I can do some demo here. Hopefully network is better now. Yeah, I need to switch to my laptop. Since we are waiting for the demo, so does anyone have any question on what we just discussed?
If you've got a document that's been sent to a client, and then you have since revoked access to the document with the client's offline, is there a timeout period that document they're allowed to access it for?
Yeah, I think Yeah, from your question, I can understand you do have some experience with on this. I'll show you the option here. So shocking. When author give the access to the end user recipient, there's an option to choose whether you want to immediately revoke the user access to the document. By default, if you don't configure this, the license which the consumer of document received from the Azure RMS is valid for 30 days, which means when you first go through that complicated process, which will wait for a couple of seconds, even a minute, and will only happen once in the 30 days. Then when you further open the document, you don't need go through the RMS again. You just use a cached license to open the document. But if the author choose say, I want to have the privilege and the opportunity to revoke the user access anytime, then the cache function will be disabled for that document, which means the user will need always go to the RMS to get the license whenever they open the document. Does that answer the question? Yeah. I think it looks like it's much faster now. It's through my Telstra 4G mobile. I just want to create a very basic document. Let's say call Ecolite 1. I put. Can you guys see this? Okay. Now I just put nothing here. Then I have a. You can see I right-click the file. This option called Protect with RMS. I have this option because I have RMS sharing application installed on this Windows 7 operating system. I can choose Protect in place, and I can choose Shared Protect, which means I'll protect, then open my Outlook to send document. So it's essentially the same thing. You can see this is a cache folder of RMS client. What I'm going to do, I'm going to delete everything here. I'm going to delete. Then I will do the operation. You will see what happened over that folder. You can see this file we know it's nothing, right? So it's just nearly empty. The size is 7 bytes. So I'm going to protect this document. I'll choose just customer permission. As we discussed, because I clear my cache, which means I need to do initial authentication, communication with Azure RMS. It should open a dialog for me to do the authentication. Yeah. Yes, I think it's opening now. Now I can see in that folder which I delete all the files, there's 2 files appeared. Those are the self-signed certificate which is generated by RMS client. At this point, I haven't talked to Azure RMS server yet because I haven't authenticated with myself. So those 2 certificates are self-generated by the RMS client. So I might just use this user. So this is from a federated domain. It's brandonj.org. So you can see that you will see the switch is switched to my on-premise ADFS and to do the authentication. So after I Yeah, after I successfully authenticated myself, and then I can grant permission to other users. Let's say I just do very simple, E01 at another tenant users, brandj.net. So I just give any access here. So you can see here, there's one option called allow me to instantly revoke access to this document. If I choose to do that one, the catch function on the consumer side will be disabled for this document. Now I can receive if I enable this, the user will receive notification by email whenever any user successfully or unsuccessfully open the document. And I can also say when this access will be expired. So I say apply. You can see that does take a while. Now I can see the file size, right? So it's become 43K because of this embedded encrypted key, encrypted license. And here on this folder, you can see multiple files. The other difference between the certificate issued by IMS server and the normal certificate authority server is it doesn't end with CER. So you can't open through by using a certificate management console. So it's end with DRM. So the GRC actually is a RAC. It's a global identity certificate. The COC is client license certificate, which is used to sign the license embedded in a document. Yeah, so now I just copy this file back to my Microsoft laptop. Here. So I have physical access to this file, but my credential still, so my Microsoft credential is certainly ended with something at Microsoft. So I just use my Microsoft. You can see I don't have access because, of course, you can see I only give the users E01 at brandon.net access. So I'm going to access my another file, another laptop. Again, I don't remember which user I used to test this. I just delete everything. And then I copy that document to the other server and the other laptop client. So I'm going to try to open this. Because I clean the cache, so I need to do authentication to the initial communication with IMS server. I think I use this one, right? Do I? Yeah. So this is authenticated with Azure AD. It doesn't have a federation configured. You can see that I can open this because I do have the permission on this file, and which is given by the author. That's a very simple demo here. I mentioned the Azure RMS can integrate with the on-premise server, Exchange server, file service. I just do a quick demo. You must think that's horrible difficult, and actually it's very straightforward. I'll probably finish the couple slides, then come back to this. We don't have a lot of time. We have three versions of the client. The first one has been very legacy before Office 2010. So if we do use this on Office 2010, you do need a couple of additional configurations. And the MS IPC, if you can see from the folder where I clear the caches, that is the current version of IMS client for Windows operating system. The mobile client is specifically designed for mobile devices, which usually don't have the power to generate so many certificates. This process has to be much simpler. And this is IMS sharing application, which I install on my laptop, which I can right-click and see that option to encrypt and open the document. This is the process how the mobile client works. You can see it's much, much simpler than the rich client. So there's no any certificate which will generate for the mobile client. So the client, every time when the client do the protection, it will authenticate with Azure RMS through the Azure AD, and then once it's successful, it will get the public key of the certificate and sign the license, embedded the files. Then I guess you might have the question on that, if it is simple, why it's so complicated on rich client? You can think of this, the key has to be transported inside SSL. So the whole security of this solution is based on how SSL is secured. If you have experience with HTTP inspection, you will know even you have HTTP, you might have HTTPS inspection, some man-in-the-middle attack. But this is the way how to work on a mobile client. When user consumes the document from mobile devices, do the very similar thing, just authenticate with Azure AD, then IMS will give the license to the client. So very straightforward, but less secure. The other drawback is because the mobile device doesn't catch any certificate, so you can't do the offline operation. So every time when you protect a document, consume the document, you have to be online to talk to IMS and Azure AD. The cross-premise workload integration, which means the Azure RMS can integrate with your on-premise file server, Exchange server, and SharePoint server, which I'm going to demo with you. Have a quick look on my environment. This is my ADFS server, AD server, and also the RMS, the server with IMS collector installed. That doesn't come out. I have IMS collector installed. So the process to set up this integration, the first thing is to install the IMS client on a server with internet access to the cloud. And when you do the configuration on the first time, you need to provide a global administrator of your tenant. So just to mention the information, Azure, you can delegate a group or user to manage your Azure RMS. If you don't do that, any user who is global admin of your tenant will automatically be administrator of your Azure RMS. You can delegate admins. Once you delegate, once you delegate, then this undelegated global admin won't have global access to your Azure RMS. So once you authenticate, once I provide my global admin to authenticate with Azure RMS, then it will identify my tenant if I have Azure RMS enabled. Then on this console, I just need to delegate who can talk to with me. So the collector essentially is a proxy. So for any on-premise internal on-premise server without internet access, they can talk to the collector which is essentially like proxy, then proxy all the communication through the collector to Azure RMS. So I already have that configured. That's my file server, which is also the SQL server. So on the on-premise file server, you just need to change a couple of registries and let the RMS client talk to that collector. So you just basically do the server location. I have one FCI, which is file server classification infrastructure task configured. And I'll apply, so I define the management task. The scope will be that folder. The action will apply RMS protection on the file in that folder. So I choose RMS protection. So you must see there's two lists there that's called template. Because once I authenticate, my attendant has been identified. So that all the template defined in my Azure RMS will be downloaded to the client. So I just apply that one of them. I also have a condition say if any file with encrypt as part of name, it will be automatically protected. So I'm going to create a very simple file called encrypt me. That's it. Of course, you can configure this task how often it will be run. To run. So, but this one will run daily. Of course, we can't wait for that. So I just run this file manage task. We should be able to see the size change of this file. Oh no, this won't happen because there's a typo on the file name. So you can see 0 file has been protected because I didn't type the name properly. So I need to change the name to encrypt. Then I'm going to run this again. Still running. Yeah, finished. Yeah, we don't have time to troubleshoot the problem. I just run again. See if it works. Yeah, if it's successful, you will see that the file size has been significantly increased.
Can you do that on metadata or contents within the file, not just the file name?
Now, that's the FCI configuration. I think you can. I'm not expert on FCI, but you can see here, you can define all the different rules. And the RMS is just one of the actions you can take. One thing I probably can mention here is you get 3 different type of actions. The RMS encryption action type I choose can only apply on Office document. Okay, that's the reason why it fails. Yeah, okay. If you don't say yeah, if I change that, it will works. Yeah, that's the reason why it can only apply on Office document. But we do have methods, a tool published. You can use this very complicated process, which I don't think is suitable for demo. So then you choose the customize action. The customize action, you can call that tool to encrypt everything in that folder. Yeah, so by default, that RMS action can only work on the Office document. But we do have the tool which has been published. which is quite a complicated process if you follow. Then you can cause customer action to encrypt everything. And I want to do the very quick demo if I have, I think I only have 5 minutes. I probably can only show you, I'm not sure I have. Of course, it can, as I said, mentioned, it can integrate with Office 365. As you see here, on this Exchange Online management portal, you can define the RMS rules. For example, one of the rules are defined is to so if the title or body of the document have a Google or Apple, and we say it's don't forward. But its exception is if it says orange or fruit there, which means it's not really a competitive related email, you can just simply ignore it. Let's say let me, I'm not sure if I have time to finish this demo. So I just send the title with Apple as a title of the email. I send to my Microsoft work account. I suddenly receive so many emails. Sorry, it's not that. Yeah, I'll have a couple of slides. I'll quickly go through them, and if we have time, we can come back to that. So as this demo, you can integrate with on-premise service and Exchange Online, SharePoint Online. And standalone, it's a very huge topic. And traditionally, this technology has been really, really difficult to implement it. For example, without this cloud, if I want to send an encrypted document, protected document to the people in IBM, they won't be able to decrypt them because they won't have, their RMS don't have the key of Microsoft IM server. So certainly we won't give the key to them, so they can't decrypt the document. Or we have established trust, which means we have AD forest trust or AD trust, so their user will be able to authenticate by our Active Directory. And that is also not possible. And then the last solution is to establish federation, right? Use ADFS to the federation authentication so the user in their organization can be trusted by our organization. Then we can give the user license. That's a horrible difficult. Now with Azure AD, and any organization who sign into Azure, they will have their tenant. Then all the tenants, they are embedded trust with each other because they will authenticate eventually, even though they have federation with the on-prem security token services. That ticket token issued by the on-premise security token service will then be reprocessed by Azure AD. Eventually, the token will be always issued, signed by Azure AD. So they're from a single entity, so they trust each other. So the collaboration has been much easier. So who can use? Anyone can use. Even if we encrypt a document, protect document sent to someone which we not sure whether they have Azure AD tenant configured, I'll probably the demo now. So the user can still sign into it. So for example, if it's from Contoso, the Contoso hasn't got the Azure AD tenant, but the end user can just sign in and create, on the back end, we prepare the Azure tenant free for them. They might have lots of users in their organization, but that's transparent to them. So they can authenticate with Azure AD, then the protected document can be consumed and opened by user from their organizations. So any user, essentially, any individual can sign in. But the only limit at this moment is we don't support the commercial email like Gmail, Hotmail, Hotmail, and other consumer email addresses.
So Microsoft accounts don't work?
No, Microsoft doesn't work. So even though you might think it's still Azure AD, but it's a completely different identity store. And we also call IMS for individual. I only have one title. Because of the criticality of the IMS server certificate, the private key has to be very, very secured. and in the high security module. And some customers even don't trust us. They want to say, we don't want the Microsoft certificate keys. We want to use ours. Lastly, I think if you want to do this, you have to have someone fly to Redmond, give the device to us. This is the Thiel. If you use Thiel's HSM, they provide an over-the-wire solution. You can shift your your private key over the wire to our data center. We will use your key, not our keys. Yeah, but that's just one of the options. Policy, which is just a template you can define on the tenant level. You can define who can apply this policy, and you will have all the default settings configured in that template. Yeah, I think with our demo, this just says you can do the ad hoc permission settings. Yeah, if you have template defined, you just apply template. All the settings in that template all can apply. I think I'm a little bit overrun, so I really appreciate that time. Thank you very much for your time. I know it has been very, very dry. I apologize, I can't make it simpler. Hopefully you enjoyed this session. By the way, I guess probably one more slide. If you have time, please do give us feedback. Thank you very much for your time. Have a safe trip home.